Hello everyone, welcome to Calculus BC. We're talking about lesson number 37 today, which is parametric equations. So one of the things that differentiates parametric equations from normal equations is that we actually have a t in our function. So usually when you're given a parametric equation set in calculus, you're given an x function and a y function all in terms of t. So one of the very first things that they're going to actually ask you guys to do is something called eliminate the parameter. But before I get to that particular example, let me just actually show you guys the visual of what's happening with these problems. So if I give you the equation x equals 3t minus 1, and I give you the function y equals 2t plus 1, and I kind of want to know what's going on with this graph. So over here on our left, I've already filled in the chart here where when t is equal to -3, I plug in -3 here and find out what our x value is. And I plug in -3 here and find our y value. As you guys can see, we did here. So I did it from -3 all the way to 3. Where I want to focus really quickly is at -1 to 2. So notice that when t equals any of these values right here, we have a coordinate. We have an x and we have a y. So I'm going to take the t values and I'm going to plot them over here. But again, I'm only going to plot these four. So when time is equal to -1, t is equal to -1, then I'm going to be at -4. So x is going to be 1, 2, 3, 4, and then y is going to be -1. When t is equal to 0, then this is going to be -1, 1. And this is not time. This is just another variable. So the parameter, it's called the parameter, because t is okay to be negative. 2, 3, and then 5, 5. And if I were to ask you guys to connect these points, right? We actually were to connect these points, you guys would see that this would be able to create a line. And actually, more specifically, let me change the color of my points now that this line's green. So let me go ahead and highlight my points one more time. So if you guys look at this, the slope of this line is 2 over 3. So no matter where I go, 2, 3, 2, 3. And it crosses right here at the y-axis. So how can I find the equation that satisfies this parametric equations without doing the filling in of the chart? Well, eliminating the parameter is really what you need to do here. So for one of these functions, you want to get t by itself. So let's go ahead and look at x equals 3t minus 1. If I want to isolate t, then I'm going to move the 1 over. So I'm going to get x plus 1 is equal to 3t, and I'm going to divide everything by 3. So I'm going to get 1/3 x plus 1/3 is equal to t. So I can have this function, t equals 1/3 x plus 1/3. So what I can end up doing now is taking my y equation and I can replace my t with the expression 1/3 x plus 1/3 plus 1. And so now we have eliminated the parameter, right? It's that simple. Well, for linear functions, it's that simple. We'll get to more complicated things in the second video. But we now have y equals 2 times the function that we saw for t plus 1. So if we're going to go ahead and distribute the 2, as you guys will see here, and then let's go ahead and add the 2/3 plus 1, and we're going to get 5/3. And so you guys can see that we have now y equals 2/3 x plus 5 over 3. Well, that's the equation of this green line. That's exactly what it is. So eliminating the parameter, eliminating the t, and then solving for y or x, or just getting an equation where we have just x's and y's, rectangular form, is going to give us what this actual solution would be. So this ends up being a line. And that's exactly what you guys see if we plot these points right here. So let's go ahead and look down at something that's kind of not very common, but sometimes with domain and range. So again, you guys can see eliminating parameter is exactly what it says. We're going to find a rectangular equation, just means that we have x and y coordinates that represents this graph of the set of the parametric equations. And so in this example right here, we have x is equal to the absolute value of t minus 1, and y equals t plus 2. And you guys can see just through the steps right here that we solved for t in the equation right here. We plugged it in to this t right here, and then we simplified and we got a rectangular equation. And again, it doesn't have to be y equals, as long as it has x and y's in it, you're going to be okay. So this is the equation that we have right here. It's asking us to look on the interval from -2 to 5. We want to know what our domain and our range is for this problem. Well, first thing is we can look at this. Well, y can be anything, right? Y can be anything in this equation. So y is all real numbers. It's all real numbers. X has to be either 0 or positive, right? So x has to either be greater than or equal to 0. So we know that because it's an absolute value. So this is our starting point. This is our starting point for domain and range. But what you also have to remember, ladies and gentlemen, is you have to also take into account the original. So again, with y, in this case, our y can be all real numbers, because again, I can plug in anything for t, I'm going to get a positive number or a negative number. X, we have a graph and it's going to look something like this. So x is equal to the absolute value of t minus 1. So we know that x, again, has to be positive or greater than 0. But we're looking at the interval from -2 to 5. So we're restricting that from -2 to 5. So from -2 to positive 5. Well, you guys can see for x, the lowest x value is going to be 0, because it's going to be right here at this value for t. And then what we end up doing is, okay, seeing which one of these is higher. So if I can look at x is equal to -2, then I'm going to get, sorry, if t is equal to -2, let me change that up for a second here. When t is equal to -2, then plug in and see what we get here. Well, we get x is equal to -2 minus 1 is -3. Absolute value of 3 is 3. So we know that the high value right here is 3. Well, let's see what's going on this side. When t is equal to 5, we're going to plug in 5 to our function. 5 minus 1 is 4. The absolute value is 4. So I know that the domain of my function is going to be 0, 4. It's going to include 0 and not include 5, because again, these are open brackets. Range, well, my y was not restricted ever. So it's all real numbers here, all real numbers here. So all I simply have to do here is plug in -2. So when t equals -2, y is going to be equal to, well, that's going to be 0. And then when t is equal to 5, again over here, then I can plug in and I get y equals 7. So my range is going to be on the interval from 0 to 7. And the reason I know I can do this is because this is just a straight line. It's just a horizontal line. Sorry, not a horizontal line, it's a straight line. So I know I can do that. So that's all you have to know for domain and range. But just remember that you have to look at, and this was also in pre-calculus, you have to look back at your actual rectangular equation, and you also have to take into account the domain and range restrictions for your parametric equation as well. So there you go. That is how you do domain and range. So let's do one more, maybe two more quick examples of how to eliminate the perimeter. But one of the things that they're going to ask you guys to do is to identify the curve and then state the domain and range. Now I'm going to go ahead and save some time here. I'm not going to worry about domain and range right now for this moment in time. My goal is to really focus on how to eliminate the perimeter. So it does not matter which one of these you solve for t. All right, and the linear ones are actually really awesome to do. So and notice I don't have any restrictions right here, which I will have over here, which we'll talk about in a minute. So I'm going to go ahead and do this one. I like this. So I'm going to say t is equal to y plus 1. I just think that's much easier to do. And then I'm going to go ahead and do x is equal to, and I'm going to plug in my t for y plus 1. So just straightforward substitution. And so I technically could simplify here. I mean, I could typically be done with it. I mean, this is eliminating a perimeter. I'm good. But the question is I want to know what the curve is. I want to be able to identify this curve. And so let's go ahead and simplify it a little bit more to make this better for ourselves. So we're going to get 2y plus 2 plus 1. And I'm going to get x is equal to 2y plus 3. And so what I'm going to end up doing is I'm going to move the 3 over. So I'm going to come up here and I'm going to do x minus 3 is equal to 2y. So I just subtracted 3 from both sides, and then I'm going to divide by y, or 2. So I'm going to have 1/2 x minus 3/2. So I know that this is going to be a line. So I know that this perimeter right here would be a line. And it's very simple to the example that we just did at the very top of the page. So this is a line. Because it's a line, our domain and range for this would actually just be all real numbers for both, right? Because it's a line. It's a line. It can't be restricted. X can mean anything, Y can mean anything. So let's look over here at this next example. We are restricted from time, for t, I keep saying time, and it's not time, sorry. Well, from t being -1 to 1. So this is pretty awesome. They're saying that y is equal to t. So let's go ahead and solve in for x is equal to the square root of 1 minus y squared, right? Because t is y, so we can do that. We want to, again, we've now eliminated the perimeter, which is amazing. It does get a little bit more complicated than this, but it's okay. We're going to square both sides, because again, we want to kind of see what this is becoming. And we're going to move the y squared over. So we're going to get x squared plus y squared is equal to 1. So we can clearly see that this is a circle. This is a circle with a radius of 1, right? With the radius is equal to 1. Now, what we have to do here is look at our graph, because remember, we're only eliminating it from -1 to 1. So what I like to do, and what I choose to tell students to do, what I highly encourage students to do, is do like a little table for a second and kind of see where our endpoints are going to be for this. So again, like the table that we did at the very top of the page. So here, time, I'm going to go -1 and 1. So if I plug in -1 to my function for x, I'm going to get 0. And actually, as I plug in 1, I'm also going to get 0. So this is going to be 0, 0. If I plug in 1 to my function, well, -1 for y, well, that just gives me -1 because they're equal to each other. And then if I plug in 1 here, I'm going to get 1. So what I know is that when time equals -1, I'm at the coordinate 0, -1. So I'm at 0, -1. And then when I'm at t equals 1, I'm at the coordinate 0, 1, which is up here. I know that this is a circle. I know this is a circle. So another thing we could do is we want to figure out what's going on with the rotation of this if I plug in 0. So like when time equals 0, I wish I'd given more space here. But when time is equal to 0, then, so let's put this up here. So when time is equal to 0, oh my God, I keep saying time. I'm so sorry, this is not time. I'm so used to that. Parametric, when t equals 0. So all the times I'm saying that, I apologize. It is not time. When t equals 0, you're going to plug in and you're going to get, for x, you're going to get 1. You're going to get y equals 0. So you're up here at 1. And you already know the shape is going to be a circle with radius of 1. So then what we end up doing is we start graphing a circle. And sometimes it's going to ask you to look at the actual direction of what's happening with this parametric equation. And so what we end up seeing and what you guys will see on paper is you will see that there will be arrows that will be pointing randomly. And that's exactly what this is. This was our starting value. This was our initial value, right? When time, oh my God, when t is equal to -1, let's see how many times I'm going to do that. When t equals -1, we actually had the value 0, -1. When t was equal to 1, which was our final spot, it was 0, 1. Well, we knew the direction. We knew we were going to go this direction instead of this direction right here, because again, when we looked at time equals 0, we know we're at 1, 0. And again, we know that we are looking at the circle with radius of 1. So we're looking at the right-hand side of it, all right? We want the right-hand side. And another reason that we know we want the right-hand side, and it's pretty obvious up here, is that look at the equation that's given to us. X is equal to the square root of 1 plus t squared. Guys, this is letting us know that x is positive. X is going to be positive for this entire parametric equation because it's the square root of 1 minus 2. So we know we want the right-hand side. That's another way of thinking about the question without plugging any values. So that's good for this video. We did solve a couple of parametric equations. I'm going to show you guys more elimination of parameters in the next video, and I'm going to try my best not to call t time because it's not. So I'm going to leave it there for this video. I will see you guys in the next one.